now conceivable to think that our children's children will think of the term cancer as only a constellation of stars. President Bill Clinton on the success of the Human Genome Project in 2000. Hello, my name is Byrn McNabb, and I'm here today with my colleague Luisiana to talk to you about the University of Texas MD Anderson Cancer Center. As many of you may know, everyone in the world, including myself and those of you in the audience, may be and most likely will be affected by cancer in some way throughout your lifetime, whether it be a family member or yourself personally. That is why we're here today to talk to you about the founding of MD Anderson, as well as current research and treatment being done at the facility, research being done on how to improve these treatments, some groundbreaking science, and where this is going and how this will benefit all of us. So I will start off with the founding of MD Anderson. So Monroe Dunaway Anderson was born in 1873 in Jackson, Tennessee, to a banker and minister. He then grew up to be a banker himself and ended up founding a company with his brother in 1904, otherwise known as King Cotton. They moved this business into Oklahoma in order to further monopolize on the business because at this time cotton was a very large industry. Within this, he realized that they needed more shipping options and moved to Houston in 1907. With this, they had access to deep water ports and then therefore more exporting ability for the cotton. He had accrued so much wealth by 1936, he decided that he needed to create a charitable foundation in his name and delegated $300,000 for this. By his death in 1939, $19 million was donated to the MD Anderson Charitable Foundation according to the MD Anderson website. From this, the MD Anderson Cancer Center was founded through UT. In 1941, the state of Texas actually approved UT finally for the Cancer Center, told them they had $500,000 to spend on such, and MD Anderson Charitable Foundation, with no place to put the $19 million that they now had, told UT, if you place the building in Houston and name it after the benefactor, MD Anderson, we will gladly match the $500,000 donation. I will now pass this over to Luisiana to talk to you about current treatment and research going on at MD Anderson.
I'm excited to tell you about some of the most current cancer research and treatments happening at MD Anderson right now. The most current project, according to MD Anderson, is that of immunotherapy. Immunotherapy is essentially treatment using the body's own defenses to fight cancer. It basically boosts your immune system and can help your own system be used to fight cancer. And that's done through the help of two cells already found in your body, that of T cells and B cells, as you can see from the little graphic here. T cells are a kind of white blood cells that can help attack invaders from inside of the cell, while B cells are antibody factories that can help attack invaders from outside of the cell. Now both cells act as a sort of tag team and can help ward off invaders from your body, making sure that your body actually gets rid of foreign cells and anything that doesn't belong there. Now this method is so great because it is a lot less detrimental to your health, according to the National Cancer Institute, as for example chemotherapy can be, which not only targets cancerous cells, but it also targets healthy cells in your body. Now, moving on to the future of immunotherapy and utilizing it for further treatment and research, it's important to note that cancer is a really insidious disease. It's clever and it can hide from your body's immune system, and each person will develop their own specific cancer. According to the National Institute of Health, no two cancers are the same. Two people who have lung cancer can have completely different cancers, so there really is no cure-all. There's no kind of medicine that can just be given to everyone and it'll work. So in conjunction to immunotherapy, there's something called adoptive cell therapy, or ACT. And this is, and according to MD Anderson, it's basically using your own cells to fight off the cancerous cells in your body. And what's so great about this is that it actually helps at an individual level rather than just attacking it in general. So it can be tailor-made for you. It can help enhance immunity as well. And this ACT can be enabled by using monoclonal antibody production, which is essentially lab-produced molecules which can help enable ACT, or can help enable your own cells to fight off cancer. Now, this alternative method is currently in use, but because our researchers are using just some of the most cutting-edge technology, and technology is advancing at a rate faster than we can ever anticipate, researchers are finding a few setbacks. Currently, and according to the National Institute of Health, the monoclonal antibodies can be a bit unstable. Now I'm going to hand it over to Byrn so she can talk to you about how researchers will move forward.
Thank you. So theoretically, monoclonal antibodies are unstable. This has been shown in some research that has been done already. They're actually paired with tumor cells to create these antibodies, which is what makes them unstable. So then we move into the recombinant monoclonal antibody. The image shown here is actually of a test that I was able to do over the summer showing that these are more stable. These green cells here and here are what prove that these can be created in the lab and that they are more stable. The reason being, all of the testing and all of the things that need to be sorted out at the beginning are done at the beginning. Previously with just monoclonal antibodies, it was done at the very end of the process, so you never knew what you were getting. That's why this method is the future of this research and will further enable ACT to be successful. So now I'm going to move into the conclusion, and I would just like to remind you that we discussed the founding of MD Anderson and how he created a business out of cotton and banking, not out of actual medicine. And then we moved into current cancer research and treatments, talking about immunotherapy and how it is better for you than chemotherapy as well as radiation. Then we moved into more about immunotherapy and how it is the future of cancer research with ACT and monoclonal antibodies, as well as groundbreaking science on recombinant monoclonal antibodies. I would also just like to say thank you for listening to us today. It was a fun presentation. I appreciate it, and we would like to open it up for questions. Thank you.